Okay, students, so now we're going to do the same thing, but in reverse. So now we're given the hypotenuse. All right, we have the hypotenuse. Now we got to find the legs. All right, and remember, this is an isosceles triangle. So we can, using Pythagorean theorem, we can say A, B, and C, or we can just simplify it and call them A and A because they're going to end up being the same length. All right, so again, A squared plus A squared equals 7 squared. All right. Now, again, remember this is like a 1a squared plus 1a squared. You got to combine like terms. It combines to 2a squared, not a to the power of 4. Common mistake. And then we get 49 on this right-hand side. All right. Then what do we do from here is let's divide both sides by 2. And we're going to keep it as a fraction. Why are we doing that? I'll explain later. But nonetheless, take the square root of both sides. Now, this is going to become a little bit of a sticky situation, but I believe in you guys. It's going to be the square root of 49 over the square root of 2. It becomes regular 7 over the square root of 2. All right. Now, don't forget rationalizing the denominator. We're going to rationalize the denominator. So that's when you pick the number on the bottom, radical 2. You pick the radical on the bottom, multiply both top and bottom by it. So if you were wondering why were we rationalizing the denominator earlier in the unit, this is why. Again, becomes 7 radical 2, and radical 2 times radical 2 is just 2. Whew. Okay, this was a little bit challenging, but we did it. All right, that's the most exact answer. Oops, sorry about that. In this case, the legs were 7 radical 2 over 2. 7 radical 2 over 2. All right, that was a little tricky. Let's do number B, see how that goes. All right. So again, it's going to be the same exact thing, just different numbers this time. We're going to have a squared plus a squared equals 20 squared. This time, this is going to clean up a little bit nicer, as when we divide both sides by 2, but actually simplify, we won't have a fraction anymore, we'll have 200. Alrighty now, people, let's do the square root of both sides, and we get a equals the square root of 200. So last time we had to rationalize the denominator. This time we just got to simplify. What's the largest square factor of 200? Well, that would be 100. 100 is a square. So it breaks up into radical 100, radical 2. So a will be 10 radical 2. And again, there's some kind of pattern going on here. What's the pattern? I can't tell you quite yet. I'm going to see if you can figure it out. You can also use the pattern we discovered in the last video to help you determine this one. It's the same pattern but reverse. Little spoiler alert. Ooh. C is the challenge problem this one, so it's going to be a little tricky to do C, but we'll be able to do it because we're pretty smart. Okay, so we're going to have a squared plus a squared equals 4 radical 2 squared. All right, so again, right, our left-hand side, 2a squared, nothing new with that. Remember over here, we'll be a little explicit about it. It's going to be 4 squared times radical 2 squared, because you're squaring it, so you got to square the numbers outside, square the number inside. But nonetheless, on this right-hand side, we're going to have 16 times 2, which becomes just 32. Okay, now again, if we learn the patterns, there's patterns we're learning about. If we learn them, we're going to be in really good shape. If we know the patterns, these problems will take 2 seconds. Right now, this problem right here took about 2 minutes just to get a equals 4. All right, a little bit more difficult to see the pattern going on this time, but let's see if we can figure it out. We got one more problem trying to determine what the heck the pattern actually is. Again, we know these are isosceles because we have a right angle and a 45-degree angle, so the other angle must be 45 degrees. Setting this up again. Repetition. A lot of this seems familiar by now. So a squared equals 32. Take the square root of both sides. A equals the square root of 32. which is going to simplify. What's the largest square factor of 32? Well, that'd be 16. So the square. And remember, I'm keeping both numbers under the square root. Again, the way I write things is very specific. I highly recommend you write things the way I write them down. I don't write them down this way just for fun. Nope, I write them down this way because it's the way you do the math. All right. So this is a little bit harder to tell. Let's draw our trusty right isosceles. All right, so this time we're given x. Well, what's the pattern here? If you can remember before, the pattern was just to multiply the legs by radical 2. Now to go in reverse, this is the hypotenuse. We called it x. Let me make that a different color just for fun. Style, let's make that orange. Wow, that was so much fun. All right, this is a leg, this is a leg. Well, instead of multiplying by radical 2, we're gonna be dividing by radical 2. All right, now, rationalizing the denominator, all right? So when you divide by radical 2, it's the same as multiplying by radical 2 over 2. So there's two ways to think about it. You can think about you're dividing by radical 2. In some cases, you're just removing it, or multiplying by radical 2 over 2. So then the legs would be, again, just to emphasize, it's going to look like this if you divide by radical 2, or x radical 2 over 2. Just a rationalized denominator. It's the same thing. It's the same number, just a rationalized denominator. And then we can write that out. Let's write leg equals hypotenuse divided by radical 2, or hypotenuse times radical 2 over 2. Rationalizing the denominator. All right, so that's it. And what we're going to do is we'll actually save these for next video. Stay tuned for more.